Hello, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at covalent bonding. So remember, guys, we already learned about one type of bonding called ionic. Ionic is a combination of a metal and a nonmetal, a positive and a negative. Remember, guys, it is worth mentioning that hydrogen is a nonmetal, even though it's on the left side of our periodic table. So if we take a look at our periodic tables quickly, remember, guys, we squared in this side over here, this green side. This green side, those are all of our nonmetals. Remember, hydrogen is our only exception. That's why we put it in yellow. It's the only nonmetal on the left side of this staircase. So then next we have a covalent bond. So this is a new type of bond we're learning about today. This is a type of bond between two nonmetals. Covalent bonds are formed by neutral atoms that share electrons rather than having a positive and a negative attract them. We'll get into it a little bit more later, but remember the octet rule, guys. Remember, atoms will share electrons, so they have 8 around them, but we'll get more into that later. Next, we need to know that when we form covalent bonds, we call these molecules. And then the last thing we know, the largest class of molecules is called organic molecules, and carbon is the most distinguishing characteristic. So when you have carbon in a molecule, that means it's organic. So with question 1, I wrote 2 things on the margin that should help us with question 1. We need to be identify whether it's ionic or covalent. So I started off with the 2 new words we learned, compounds and molecules. Remember, guys, compounds are ionic, molecules are covalent. Remember, I'm on the left side now. Remember, compounds, ionic bonds, are made out of a metal and a nonmetal. Metals are found on the left side of our periodic table. Nonmetals are found on the right, and metals are positive, nonmetals are negative. Over here, we have molecules. Molecules are covalent. Covalents are combined between a nonmetal and a nonmetal. So on our periodic table, we'll locate both of them on the right side of the staircase, and the charge is less important, but they are both negative. So first, a few examples. We can find an example of an ionic compound. An ionic compound would be example A, because we have calcium and chlorine. So calcium is on the left side of the staircase, chlorine is on the right side. So we know that this is ionic. An example of a covalent would be one like D, where we have nitrogen and oxygen. Nitrogen is right here on the right side. Oxygen is also on the right side. So this would be a covalent bond. So now I'll go through and do the rest. Remember, guys, little trick, hydrogen is a nonmetal even though it's on the left side of the staircase. So remember that when you are working on these. Question 2. So question 2 is the one I'm not going to help you too much with, but what you can think about is check the charges of the different polyatomic ions that are in there, which one is acting like a metal and which one is acting like a non-metal. Question 3 is just like question 1, but after we determine if it's ionic or covalent, we need to call it a compound or a molecule. So do the same thing you did in question 1. Use your periodic table to determine whether it's a metal or a nonmetal, and then name it appropriately. Remember, if it's ionic, a metal and nonmetal is called a compound. If it's covalent, 2 nonmetals is called a molecule. So next when we name covalent bonds, naming covalent bonds is a little bit different than ionic bonds, and you'll be happy to know that I do think it's a little bit easier. When we name covalent bonds, we use prefixes. So up here you have a little information. So from this, we can figure out what some of these prefixes are. So on the bottom, I want to do example B. So we need to figure out what the prefixes for 1 and 4 are. So we can analyze this table up here. Look, where there's a 1, there's no prefix, 1, there's no prefix. Oh, but we do notice that when there's a 1 over here next to oxygen, the prefix is mono. So the first prefix for 1 is mono. That is a little special rule that you might have noticed when I was going through this, is you don't use mono in the name if it's the first ion. If 1 is the first ion, we don't use the name. That rule will make a little bit more sense down here when I show it to you again. And then we also need to know 4. So 4 is located right here on the oxygen. The prefix in front of oxide is tetra. So we know that the prefix for 4 is tetra. So you guys can identify the other prefixes the same way. Look up the number and then pull off the prefix. So, covalent bonding rules. So when we are working on covalent bonding, we know that the prefixes equal the subscripts. And then since all of the compounds we are working with are going to be negative, look at the ending of all of the names, all of the endings are "-ide". So we change the endings to "-ide, and we don't change the first name. The only thing we would change on the first name is adding a prefix, but we are not changing the ending. We do not change the ending of the first name. So down here, if we were to work on one like B, so we could start by just naming this. So we know that this is carbon. Well, you gotta spell carbon, right? C-A-R-B-O-N. Remember, carbon has a 1, so the prefix would be mono. But we don't use mono in the name if the ion comes first. So because the ion is first, carbon is 1, we just leave it carbon. We do not change, we do not put mono in the front. Then we add the prefix. So we know the prefix for 4 is tetra. We see that we have 4 fluorines. So we know that the prefix is fluor, tetra, and then we change the ending to "-ide". So because it's negative, then the ending goes to fluoride. So guys, what I want you to do, I know it was really quick, but try your best to try to name these other 3. It's okay if you're wrong or you have questions, please just write down your question. We are going to go over a bunch in class, so this is simply for you to just try it quickly on your own. So next we have a little bit of information on empirical and molecular formulas. So the molecular formula will tell you exactly how many of each atom are present in a compound. So you can think of molecular formula, you can think about them as an unsimplified fraction. And then what we are going to think about or learn about now are empirical formulas. So this page, we have molecule 1, 2, 3, and 4. We give you the molecular formula for the molecule, and then we give you the empirical formula for the molecule. So when you are thinking about this, I'm not going to help you too much on this page because you already know a lot about this about fractions. I want you guys to try to compare what you know about fractions to molecular and empirical formulas, and then we'll go over it together. So a few hints that I will give you. So the first thing is I'll tell you right now what the empirical formula is. So the empirical formula is the reduced formula. So if you were thinking about an empirical formula, if you were thinking about molecular formula as an unsimplified fraction, empirical formula is a simplified fraction. Or you can also just think about it as a reduced formula. So then what you can think about is when the other formulas that we have reduced in the past. So we have calcium and sulfur. Calcium has a positive 2, sulfur has a -2. When we crisscross it would become Ca2S2, but we reduce that to CaS because a 2 to 2 ratio reduces to 1 to 1. So look at how these formulas were reduced and think about fractions. You can use what you know about fractions to answer questions 6 through 12. So give them a try. We'll go over them in class. Remember guys, it's not important that you get all of the questions right. It's important that you attempt every question. You will get all of the points if you attempt each question or if you write down where you got stuck. So like always guys, I'll try to end these with a joke. So, where is an astronaut's favorite place on a computer? It's the space bar. I hope everyone has a wonderful day and I will see you next class. Bye.